Hello, this is our third video on this series using Creo surfaces, and we have been using a model that is battery to model a battery in Creo. But the aim goal is for you to understand how to use all the surfaces features in Creo. And for me, I like using an actual model and explain into depth, into detail. On our last video, we were able to import an image, this image here, for the bottle front view, and we were able to create these boundaries to help us to define our sketches. These are very important boundaries we created in our video. Today, we're going to focus on creating this profile. We call it left and right profile. I'm going to use splines. Then we're going to create this neck surface and bottom surface. Just that. I want to move slowly for you to understand how to use all the features we are going to use in modeling this bottle. The first thing we need is we need to extrude the bottom surface. We're going to start the bottom surface here, moving up. Therefore, I need to go to model here and select extrude. You can decide to create a sketch, then extrude the sketch. But for me, I like using extrude so that we can have the sketch internally. You can see now the sketch here. You define sketch internally, and here is how you define a plane. You can check my previous video where I discussed into detail on all these features here. Use previous, flip, references, or orientation, and you saw the effect of that. Select front and sketch. I need now to use references and now to reference this uh, bottom curve. You can remove it if you select something by mistake and select this edge, this edge, because I want to create a line from this point, and this line is dimension 111. You might ask why I've used 111. Because let me just show you why. Because I don't want to go all the way to end. I just want to have enough. If you draw a line that tangent to this edge here, it stops around there, because eventually we'll have a curve that will go like this. It will stop around there. You can make it towards 110, whatever the value. Yeah, that makes sense. Therefore, let me just delete this and say okay. Once you exit the sketch, you get this warning. This means that the default is supposed to be solid, but now the software is going to switch to surface. This default here, you can use config here to switch it and off. For mine is default is solid. I think I switched it off to solid sometime back, but we can find it here and switch it off and on. We have so many config, but I won't discuss about them for now. But just know you can always have a default. Whenever you extrude, whenever you revolve, you can have a default such that your software creates solid or surface. For now, use any value, but now use 70 to ensure that we are defining our features properly. And this one here is my bottom datum surface. What is it? Bottom datum surface. Next, I need now to define the bottom profile. This battery has a certain profile. I want to define that profile next. I'll sketch here. I'm going to use this point as my reference as well as this cross. Now continue sketching. Let me use center lines here. If you draw such a center line by mistake, you can always make it vertical. I want to use conic like that. Then another center line at this point here. Therefore, dimension, if you select your arc, control this point and this line here, you can say 90 as well. This one here, this point, dimension to be 82, raw to be 0.5. Something else, in case you have a dimension here that is not, the dimensions that are created automatically, they are called weak dimensions. Like this one here, if you put your mouse there, you can see it will be written 0.5 weak, but this one is here 90 strong. This means that dimension can't change unless you change it. Hence, it's a strong dimension. These are strong dimensions are dimensions that you define. 45.37 is a weak dimension because if you move things around, this will start to change. Okay, therefore, let me just illustrate that with an example here. You can see these ones are all weak dimensions, all of them, because if I move my line, you can see they are changing. But if you want them to lock them down, you can just select the dimension, go to operation, convert to strong, or then say okay. Therefore, it becomes strong. Otherwise, you can say select, then Control T, enter. It becomes strong. Something I wanted to mention to you. Then from this height to this height here, call it 28.5. That's predefined, but this is still weak. Do not leave weak dimensions, otherwise they are going to change. Therefore, select this one here, operations convert to strong, then enter. Therefore becomes strong. Next is we need to do a spline. Create a spline here. That this spline to be tangent to the conic here. You have to press Control, then dimension here, spline this edge here and this line to be 90. You can see now we are going along direction, hence becomes 0. We can have 0 dimensions in Creo. Then these points here, 12.8. Next is 26. Let's see from here to here, 74.6. Just use these dimensions. These are the ones I used to create my bottle. Yeah, like that. And if reading is strong, then say okay. Now we have this curve that defines how our bottle will look like. Let me double check something here. 74.6, 51. Yeah, that's fine. You can rename your sketch as a bottom profile if you want. You can say bottom profile. Next, I need now to trim away this unused surface. If you select trim, then you get these icons appear. And the first thing you need to define trimmed quilt. You have to select one like that. What do you want to trim with? The curve. You get this arrow. The arrow points to the surface that is going to be kept. If you select arrow, it changes direction. You can see this highlight. It means we are going to keep this. Arrow points to the surface to be kept. If you want to keep both surfaces but separate them, just select here to get this gray arrow. When they say okay, you see now we have two surfaces kept. Okay, therefore for me I just need to keep in a surface. Remember, you can as well trim a surface or a curve. You can see here. Next is properties, is where you define the name. You can give the name of your trim for those people who like to name their features for ease of references. Maybe you want to go back to a model some time back and you want to understand what happened or the name of your feature. There's another one called silhouette trim that is grayed here. Let me illustrate to you what that means. You can see my bottom profile. For the silhouette trim, I'm going to use another here. Let me just use something else here for you to understand. I said I'll be going into depth. Whenever I use a tool, I have to explain everything regarding that tool. I have this surface here and I have these planes, a simple surface. If I was to sketch onto this plane, I get this type of, you can see what I'm getting. I can maybe say, let me use a line. I can attach line there and attach another line there. This line that is on the edge of the surface, you can see, those are called silhouette. You can see, if I hide my planes, now the silhouette edges of this surface is these two. These are the assume, just understand this as the boundaries of your surface. This sketch 3. If I was not to extrude this surface, let me just select this surface here. Okay, let me just repeat again. Go to front. Let me convert, project this and this onto this practically for you to see what I mean. Surface. Okay, I need one sketch at a time. Let me just delete one. One side will be enough for you to understand what I mean. Yeah. If I was not to sketch like that, let me just use symmetry like that. You'll see that this surface acts like a boundary. This surface here. Same case applies to the other side. Okay. If I was to trim, let me just go back now and let me show my planes. If I was to trim this surface using this plane, I can say trim what? This surface using this plane. When you select, if you don't select anything, well, where the surface planes intersects the surface, that's where the trim happens. You can see here like that. But when you select silhouette, if I go back to the right view, you can see this edge and this edge. The sketch, my sketch, it uses those sketches. Internally, what happens that those edges, they trim the surface. You can see now the surface trimmed. You can see this edge here is this edge. The bottom edge is this edge. If I go back here to my surface, you can see now this edge and this edge, this surface, they meet. because it creates this surface internally and it cuts the surface. This surface becomes my trimming tool. It trims the rest. I could have used these two surfaces to trim, or you can use a silhouette. I hope you have understood what is silhouette. For that is the external edges used to trim a surface. Basically, the software creates a surface like this and uses it to trim. Therefore, I go back here. This bottom profile is this profile here. I'm talking about this surface here. Okay, I hope you have understood that. Next is we need to create the neck here. Let me go to front. Then I need a surface here that represents the neck. The easiest way is to use a revolve because this neck is circular. Because it's circular, I'm going to use a revolve. Sketch, define. Define which plane? Front plane, and use sketch. Then I want to use a reference of this cross, use a point. This point, can see we have a point, center line. These ones are called sketching entities. These are the entities that exist inside sketch only. For example, if I use center line, this center line will always exist in the sketch. But if I use this center line here, this center line will always exist in the model. Those are the differences. These are datums. You can see datum, coordinate, datum, point, datum, centerline, but these are sketching. Sometimes you might use a datum coordinate system to define something. Maybe you want to define something from this datum. You can use a datum coordinate system. But for now, I want to use a point that will exist here. I want to use this as my center axis. For you to revolve, you need a center line. That's the reason why I've used a center line and a point, because I want the center of this. At that point is the center of this line. Then this curve, I have to consider it as well. Therefore, create a line. Around there, use your 3-point arc from this point to that point, like that. And your tangent, make it 65. 65. Around there. Yeah, that's fine. Okay. Now we have my revolve. We have defined the internal sketch, that is internal section 1. You can edit and go back to the sketch if you want. Oops. And the internal axis. For you to revolve, you need a central axis. This axis is the center line that we have defined. The reason why we are saying internal central line or internal axis here. Angle. For the angle, you can use any default can write yours, but for me, I want 180. I want to revolve half because this is an asymmetrical model. Just I'm going to model one side, mirror to get the other side. If you want to go the other side, you can just interchange here like that. Options in case you want to revolve second direction is like how you extrude one side. Similar thing. Properties, if you want to rename, maybe I want to give this a neck surface like that. Options, capped edge. Capped edge is usually used when you have, for example, when you want to create a cylinder, you can cap edge. Let me illustrate quickly here. The quick one. Revolve, sketch, like that. Just want to use a center line here, like that. Use a line here, like that. Quick one, can see. If I go to options, then I don't have cap edge. activate, let's say, properties. Okay, it is deactivated, but sometimes cap edge means this surface here now gets crossed. This surface here and the bottom side gets crossed. Let me use a sweep. I think sweep might make more sense. Quick one. I'm doing this because I want you to understand how to use everything. Surface here. Options, you can see capped edge. When I say capped edge, now the openings, a surface is created on the openings. Capped edge. That's how you use capped edge. Okay. Therefore, I hope you have understood how to use revolve and capped edge. Next is creating splines here onto this surface, onto this plane. I want now to trace this side profile, and I'm going to give you some tips and tricks on how to use spline. I just need first of all to take these 2 points, that point and this point here for reference. Then select your spline. If you put a spline like that, you are like, how do you put the next point? Most people, they put points randomly. No, the best way to apply points is whenever you are changing direction. Right now, I'm getting down, but when I reach a point here, I start to get direction to go in. When I reach point here, I start to get out. That's how you apply points. Whenever you see a change of direction, put a point in splines. Therefore, I could have put another point. I could have used a point there. Another point here, I'm changing direction. I'm changing direction here. I'm changing direction there. I'm changing direction last 3 there. You can see my spline will need very little manipulation. When you double click your spline, this means we are sketch mode. We are controlling or edit type. We either use control points or interpolation. These are called interpolation points, but we can use control points. For me, I like control points because they enable me to move a point considering your neighboring points. You can see it was easier. It was easier to put these points when you consider that method I've used. Whenever you see a change of direction, put a point. There's this one called a curvature analysis, enables you to analyze your curve. You can see this curve is so bad. You can't use this type of curve in surfaces, but I'm going to use it. I'll show you how you can fix this. You can see you can never use from positive, negative, positive, negative. Avoid this. We are changing the gradient from negative to positive. I've used this display. You can vary the scale here if you want, like that if you want. These two, to be honest, I've never used them for fit and fire and this. If you want to add another point, just right click. First for right click. Let's first for say okay. Let me double click again here. You have to make sure you are in interpolation point. Then right click, add point, or right click, delete point if you want. Okay, but make sure you are using interpolation points if you want to add a point. Let's say okay. Let me just leave that as like now. I'll show you I'll show you how the best way when you are creating this. Again, go to the front and do a sketch. Go to model or something here. Say okay. Front sketch. Again, references. Don't select this one. Select this edge at this point like that. Orient your sketch, your screen, spline, this point to change. Instead of now going back and forth, just go straight. You just go straight. We're going to we'll use what we call, once we create the surface, we'll now create this one and trim. Instead of using one curve, you can use just two curves. Another curve here to avoid what I said, changing gradient from negative to positive. This one here, yes. Now you have understood how to use these points. Yeah. Do I need this one here? Yeah, maybe. Don't know. Maybe no, maybe yes. Yeah. And here a little bit. Yeah, that's fine. That's okay. You can see now we don't have a negative. We don't have like a sine wave. Okay. Lastly, I'm going to create another curve now that defines the central profile. This one is called right profile, like that. This one is called left profile, like that. But now I need to define the middle at the center here, and I need this to use these curves as my datums. But for me, I like using, instead of using a surface or a curve, for me I like using curves, datum curves. Therefore, I'm going to use what I call quilt. Select the surface here, and again go back to the geometry and this plane and select intersect. Whenever they intersect, they are going to create a curve. Where the plane cuts the surface, it creates a curve. Intersect one. Same case applies quilt control, say intersect, another curve is created. You can see here. Therefore, now I can go to this plane here. Just go back to geometry. Sorry, geometry. Select here, do a sketch. Now I can easily select this point as my reference, like that. Then use a spline from this point, that point there. And this point, I want us to define this point as 70, like that. That's enough. Okay, we have now defined the three main curves we need. These are the three main curves. This curve here, this curve, and this middle. We have defined the top neck surface and bottom surface. The next thing we're going to do in our next video is not to create surfaces. Yeah, don't worry here, we got out of boundary. We have to keep that in mind. It's because here we didn't go back. The reason why now this surface, this edge went past boundary. That's fine. But the most important thing is to ensure this curve here will always touch the boundary. Therefore, save the model. Let's meet in the next video where now I'm going now to start illustrating into depth how to use all these surface features in Creo into depth. As I said, the purpose of this tutorial is for you to understand how to use all these features using a real world design. Thank you. Like the video, share the video, comment. This motivates me to create more engaging videos to help you understand how to use Creo. Thank you, and let's meet my next video. Bye.